This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. So last session, we were discussing about how do we do the Docker imaging part for our different applications, and we just kind of pushing the images out there. But actually, okay, so we need to consume them in, consume them inside our Kubernetes cluster. Okay, so yeah, so first of all, let's talk about how do we launch a Kubernetes cluster. So the easiest way to launch the Kubernetes cluster, so is easiest in the sense like the best way even. Okay, so around Amazon EKS is Elastic Kubernetes Service. They have provided their own utility, and so you can just use that particular utility and you can launch and delete the clusters easily. Okay, so that is the reason, or else we can write some Terraform code and do that. But yeah, so we would like to so rather than writing a lot of code, so you can just try a simple utility, so which is offered by them. So I will just use that as well. Okay, so EKSCTL. So EKSCTL, so getting starting with Amazon EKS utility. So if you just go there, they'll tell you how do you install EKSCTL. So EKSCTL create a cluster, and so you just want whatever the cluster you want. All right. So then I'm going to do the same thing. So first, let me go to my workstation, and I'll install that in my workstation. I'll execute that in my workstation. But this takes around easily 10 to 15 minutes in between to create a cluster. First, let's create the cluster, and then we'll go and talk about the orchestration and other things, like basically introduction to the Kubernetes. Then we'll talk about that. Okay, so now either you can use sudo lab auto, EKSCTL is there, so there is a sound utility, or else you can just download it manually. It's up to you. How do you do that? And it just downloads and installs a couple of bunch of other utilities as well, so which is needed. So which is another one is kubectl, which is the major one. A kubectl is also a other utility to connect to the Kubernetes cluster. Okay, so EKSCTL is to connect to the EKS cluster, which is Amazon's one. But that once after you launch a cluster, that's a Kubernetes cluster. So we need to go with Kubernetes cluster, and then we need to go with kubectl to connect to the Kubernetes cluster. Okay, so that's what we need to do. So that's the reason. So we will be so we'll be okay, so installing that particular utility also. All right, so now EKSCTL, so create so EKSCTL create cluster and hyphen name, so probably some test cluster, and hyphen region, so which is US-east -1, and so hyphen managed. So that means I'm going to say that you manage the nodes, basically I'm telling, rather than I go and create a node. Okay, so you only create the nodes is what I'm telling. Okay, so let it create a cluster. It takes some time. Okay, so let it run in the backend, and so yeah. So in the meantime, so let's go and talk about the Kubernetes. Yeah. So basically, the first thing to start with, so why Kubernetes basically, right? So there are a lot of orchestration tools and okay, so and why Kubernetes? Okay, so or first of all, why do you require an orchestrator? Okay, so even we should be starting with that. Okay, so why an orchestrator? All right, so why do you require an orchestrator? Okay, so that part if you try to understand, so okay, what is orchestrator? So or who is orchestrator basically? What not? It's not what, it's actually who is okay orchestrator. Okay, if you just understand this, basically you will understand. So orchestrator music, if you just go to the music orchestra, okay, so you'll find out an orchestrator basically, so kind of controlling everyone, so who stands in central, kind of giving instructions to everyone, so and then everyone kind of align with him, okay, or follow his instruction. So okay, so just try to music or orchestrator. So keep the nice image basically. um, okay, so one person actually who sits in, I think anything you already know that, right? So nothing much to specify, but yeah, he's the guy. Okay, so in the music, so whoever is the centralized guy who is controlling everything, so that guy is orchestrator. Okay. Okay, so why do you require him? So think about, so you go to your data center and you think about, so one Docker machine, you log into the Docker machine and you execute the Docker commands basically. But let's say you have hundreds of Docker machines, right? You have okay, so you have hundreds of machines out there. Okay, so then how do you manage them? So you require some central guy. Okay, so um, the central guy is actually trying to kind of manage everything. So that is the reason. Okay, so even in the Docker containers also you require a lot of lot of Docker images and so not Docker images, Docker so machines running out there, and you want someone actually who manages them. So that becomes a orchestrator, and Kubernetes is a orchestrator. All right, so Kubernetes is a orchestrator there. Okay, so dealing with a lot of machines out there and what they're doing, and so those things. All right, so that's how so the orchestrator has been so needed in the Docker world basically. Okay, and so we tell to the orchestrator that, hey orchestrator, I want, and orchestrator will perform on the nodes which is supposed to be performing. Okay. Okay, so yeah. The next thing is okay, so why Kubernetes? Okay, fine. So then so is there only one guy actually? Even in Docker also we talked about so there are so many container technologies basically. Okay, so why Docker? Okay, so we talked about some reasons, right? So here also there are other orchestrators which are available, like so so like whom? So orchestrators we have is Kubernetes, which is well known, and you have so DCOS. Okay, so DCOS is another orchestrator we have. Docker Swarm we have. Okay, so which are majorly and widely used things. Okay, so these one. So out of this, again, why Kubernetes is the question basically, right? So in Kubernetes, you have a lot of families again. Red Hat adopts it and keep it as um, so Red Hat adopts it and keep it as OpenShift. Okay, so yeah, like that, different so channels are there. The story of Linux I mentioned. The same way, like people, it's an open source. Like people go with different approaches there. And why Kubernetes? Basically it's backed by CNCF. CNCF is backed by mostly by Google. Okay, so a big community, so which develops the thing. So and again, this Kubernetes is actually a Google project. Okay, Google internally have some project to run the containers. They hand over it to CNCF, and CNCF is managing it. And so it has a very good community. It's a lot of community support you have, and so it's an open source and freeware as well. So basically, so people will go with that. And better than Docker Swarm solves certain problems like network and storage. Network and storage problems in Docker Swarm is quite, even from Docker Swarm is from Docker, but actually it is too complex out there. Okay, so here it is. Here it is quite better. Okay, so that is where the Docker Swarm, and it's a okay. So it's a cloud native product, by the way. Kubernetes is a cloud native product. So with the cloud only, you can get the utmost outcome of the cloud. Okay, so um, cloud is something okay, so which makes Kubernetes more powerful basically. Okay, so that is where some reasons, so why Kubernetes basically, and what Kubernetes actually is trying to solve the problem, as I mentioned. But yeah, did I not mention that? What? Okay, so I just went in other problems. Okay, that's fine. Okay, so this is a cloud native thing. Now, if you look into the Kubernetes architecture, basically, so you're going to have master nodes where your Kubernetes master or actual Kubernetes software is running. So that's called as master nodes. And you're going to have some compute nodes. Okay, manage some nodes, and those called as compute nodes or nodes of the Kubernetes. So where your Docker is installed actually. So where any container runtime is running. Okay. So and from 1.1, 1.20 version, it's actually from 1.20 version, the Kubernetes is actually trying to, so deprecate a Docker, a Docker runtime and actually going to another runtime. Okay, so it doesn't really matter whoever allows you to create the containers, and okay, whoever allows to create the containers, it just talks to that and creates the containers basically. Okay, it manages the nodes. Okay, so here what we're actually going to do is, instead of that particular master components we install and manage it, what we're actually taking is we're taking a so EKS service, Elastic Container Service for Kubernetes. Okay, so or you call it as in a shortcut EKS, Elastic Kubernetes Service. Okay, we're taking a service, and that master components are now replaced with our Kubernetes. Okay, so that's the idea. So the EKS is nothing but so reducing your burden and kind of managing all those master high availability and all those things. So it just provides as a service, and at a very cheaper cost even. So you just take it and you just okay, so take the service and you just tell how many nodes you want, and just kind of manage that particular nodes. All right, so that's what actually we are now going to use EKS. Okay, and ultimately the setting up of these master components and all is not actually a scope of our content basically. Our syllabus, our scope is not, that scope is not there, by the way. Okay, so we just use EKS only, and so we deploy our application using EKS into the nodes. Okay, when it comes to the Kubernetes actually master components, so here are the different components which we are going to have. Okay, so here is the master components. In the master components, here are the 5 major components which are mentioned out there. So the API server is a very quite busy one, so which is a very big one, by the way. So which actually, so take all the requests. Like every component, in fact, talks to the scheduler, talks to API server, etcd talk to the API server, or basically API server talks to the etcd. Okay, so controller manager talks to API server, kubelets, everyone is going to interact only with one guy, which is API server. So he's a quite big guy, and even the users also by either by using kubectl command or use k9s command or use helm command, or if you want some UIs also, so you want some kind of UI, so yeah, you specify that UI also. So those UIs also you talk to the API server only and authenticate and get into the cluster. Okay, and you have multiple components, and etcd is a database. It's a database. API server is it is the one actually you tell the request in a format of API, and that format is also kept in a YAML format, and you pass that input. Okay, so but end of the day you're going to hit the API server. So scheduler, you ask for a container to schedule, and there's someone who schedules your container to be on one of the compute node which you are seeing as a compute nodes, right? So in one of these node, actually it has to schedule. So who does this? Is a scheduler. Okay, controller managers are there. So control managers are what? Controller managers are like, so cloud control manager. So cloud controller manager is to manage the cloud components like so which is integrated to the cloud. So like let's say some load balancers, some disks, okay, some DNS records, okay, so some security components, all these particular things will be controlled by controller manager. Okay, so if it is related, so my AWS has one controller manager. Now let's say I'm running my Kubernetes in my own data center, so probably there is some firewall. I want to manage my firewall through Kubernetes. Okay, so or there is some storage. I want to manage some storage basically. So that includes the control manager. And kubelet is the actual client software which even runs on the so the node compute nodes also. Kubelet also runs here because all these actually runs as pods and containers. etcd is a pod and container. API server is a pod and container. So these are all runs as a pod and containers. To run these pods, you require a kubelet. Okay, so what is a pod, what is a container? You will see the difference very soon, but actually to run the containers and pods, okay, so here we call it as pod, we don't call it as a container because we don't deal directly with the container. So that's where we call it as pod. Here we'll just in few minutes you will see what is a pod, but here are the different components. Just try to understand. So you need to talk to the cluster. There is an API server who is accepting your request. Okay, so then you ask to create some container and the container is created. Okay, and how it maintains its state, basically it's a stateful application. So you ask for a container to create and it created a container, and that information will be stored in database called as etcd. Okay, and someone is running your request, so that means it's actually taking your container request and trying to schedule it somewhere to run it. So that's a scheduler. Okay, now once after you deploy your application inside your container somewhere, you need to expose it to outside world. So in order to expose it to outside world, you mandatorily require something on the server, something on the cloud side. So that is a load balancer, which is a default one. So that's where the controller manager comes into picture. So it does that particular part, and all these particular components runs as a pod and containers, which will be created by using a software called as kubelet. Okay, so yeah, these are the master components. But on the server side, only you just run the containers, just only kubelet is fine. That's it. Okay, so we just already created one cluster, so which is fine. And so you have a kubectl command to talk to the cluster. So here are the basic information about your cluster. So if your cluster is already up and running, we can do that, but something is going on still. It just takes longer time. Yeah, almost up, yeah. So now kubectl is also already installed as a part of EKSCTL. If you run that, so then you get a. First is cluster info. So you can just give cluster hyphen info. It will not give you much big information. It tells you what is the endpoint of that cluster and minimal things. It's telling you this is the endpoint of your cluster, basically. Okay. And what is the next one? kubectl get nodes. So kubectl get space nodes. You get two nodes are there, and two nodes are being created by our EKSCTL by default. Actually, you are using that. And kubectl get nodes -o wide, so probably it tells more information. -o wide actually is going to give you a little bit more information, telling you what is the IP address of that. Okay, what is the OS image? Also, it is running Amazon Linux 2. Okay, so and also which Docker version it is using. Also, it is telling container runtime. It's actually using Docker only. Amazon is still using Docker because it's the version of your Kubernetes cluster is, I think, 1.18 if I'm not wrong. So here, Kubernetes service if I open. Yeah, 1.18 is the version. So probably I think update came out. So 1.19 is also might be available. Okay, fine, no problem. So that's okay for us. And the next thing is, what is the next thing? So the next thing is API version. So what all the different API, you are hitting the API server. So what all the API, so API hyphen versions which are available. So if you give API hyphen versions, you'll get a bunch of API versions which you have available. So every version has certain resources to be created. Okay. Every version has some resources. Like it actually follows the life cycle of the development, right? Now you see this auto scaling V1 is there. Okay, now new features want to come out in auto scaling, so then they will introduce that in V2, but directly V2 will not come. The V2 beta is there, beta 1 is there, beta 2 is there, and after that you get alpha. Okay, so somewhere you will see alphas also. You see this alpha, so alpha and then beta, right? So first it goes to alpha, first version, so it just tests out, and it will go to the beta. Okay, so beta 1, beta 2, and probably it finally comes to the main version. So that means auto scaling V1 is already there. The new development actually is not interrupting the old version, so they're actually so shipping with some other versions. And so after that you have done with alpha and beta testing and everything, so they remove this V1 and they'll replace that with V2. Okay, so or they might give both V1 and V2. It's a choice, basically community decision, product decision. So you have that. Okay, now what all the resources? This is the so this is the versions, and what all the API resources you can create. So a lot of resources are there which Kubernetes allows you to create. These are all the different resources. Okay, and pod, whatever we're talking about, is the one of that. It's the major of that, by the way. Okay. Okay, kubectl -help. So basically, probably to get all your options around that, you can just go with this one. Now, how my kubectl is actually interacting with my Kubernetes cluster. So my EKSCTL has brought one Kubernetes configuration file into my system. So I'm using that, is actually trying to talk to that. Okay, so this is the certificate authority data, so which is not needed. So this is the server it is trying to connect. Okay, this is the server it is trying to connect. And how it is authenticating, it is actually executing some commands here. So the command it is executing is AWS. Okay, and with some options, arguments to that, so which is AWS. So it is trying to do AWS EKS. Okay, so get some token. Okay, hyphen cluster name and a test and a hyphen region, and which is US East 1. Okay, so it is actually trying to get some token like this, and it grabs the token. So since you are being authenticated, you get the token, and you get the token, and so you get the token, and that particular token will be used to authenticate to the cluster. Okay, so that's how it is going. So Kubernetes cluster uses authorization over authentication. Authentication means username and password. Authorization means some kind of tokens. So Kubernetes by default, so uses authorization, not the authentication. Okay, so authentication means some username and password mechanism. Authorization means some kind of so long data, like a string basically, for authenticating, like some tokens or something like that. Okay, Kubernetes uses this by default. All right, so yeah, so that's where how your kubectl is interacting with your Kubernetes cluster set is somewhere sitting in your Amazon by using a kube config. Okay, so which is available out there, which is available in a .kube/config file. Okay, so yeah, so that's where so we just understand certain basics of our Kubernetes cluster. Now you will be moving to the next one, so which is actually what do you run in Kubernetes. Basically, we're dealing with containers. We have to supposed to run our Docker containers, but we don't deal directly with the Docker container. Basically, what we're going to do is we're going to deal with the pod, and pod deals with the containers. Okay, why this pod? Okay, why this pod has been introduced over the container is of two reasons basically. Okay, so one reason is it will use the same storage stack. Okay, so that means if I want to share the information between two containers, it's quite easier. Okay, so if I want to share the information between two containers, it is quite easy because those sits side by side only. Okay, but in Docker Swarm, problem is one container can go to one node, another container can go to another node, unless until you group them. Okay, so you manage them, so additional management burden comes into picture. So those are actually acts as an individual containers. But actually coming to the pod, so those are actually grouped into a single roof. They're actually bought under single roof. So what's going to happen is there is never scope of launching those two containers in two different nodes, and your storage will never become complex there. So sharing the information between pod to pod is quite simpler. Container to container is quite simpler in a pod. Okay, so that's the idea of introducing pod majorly. That's one reason. And second reason is okay, they use the same network stack also. So both containers talk to each other as those are same. Okay, not actually as an individual. So component to component interaction goes on the network layer, and they use the same network layer, so in the same network stack. So that's where so even the connectivity between the containers also is quite simpler than your Docker Swarm. So these are the two major reasons. Okay, so why Kubernetes actually introduced a pod, and which which solves a lot of your burden basically. Okay, end of the day, you have multiple components, you need to connect them in a better way. So that makes that Kubernetes made simpler. And also you need to share the information, like using some persistent storage. So then storage concept is also quite simpler here, which makes life really easy for anyone to run the containers. Okay, so yeah, we can just consider these are the reasons which makes pod as a quite powerful one. Okay, so and Kubernetes uses that. And so here again in Kubernetes, so what you are going to have is it's same like Ansible or something like that. So there will be some keywords which is already provided by the tool. Just take those particular key values and fill up with your own values. Okay, that's it. And to create a pod, you're going to write one YAML file to do that. Okay, you can also use imperative and declarative. Imperative means you have to run your commands. Okay, so now kubectl get space pods. If I give get pods, you are having no resources found. Okay, so kubectl create pod and hyphen image. No, not create pod. Run kubectl run and hyphen image is equal to nginx. Okay, the name of that particular one, so which is some sample. So no, not like this. Kubectl run sample and image is equal to nginx. Okay, so kubectl get space pods. Now you see that so sample is actually running. So what you have done, it's an imperative command. Okay, so and alternatively what you have, some declarative approach by writing some YAML file. Okay, imperative has a very limited options, very limited options. So that's where we don't use um, we don't use much of imperative. So all the time we'll try to directly put through YAML file. Okay, so yeah, let's go and make that as well. And for that, what am I doing? Okay, all right. So now I will go to Kubernetes, and inside that new directory, just go for pods file. Now, so there are in any spec, now you're writing for pod spec, you're writing for storage spec, you're writing for network, okay, which we call as service here, service spec. So everything will have its own spec, but irrespective of that, so there's a quite common 4 words which is which is mandatory for any of the resource which you are creating. API version, so which API version you want to use, v1, and a kind is actually going to be a pod. Okay, so and metadata is something it is gonna look for, and in metadata name I'm specifying, let's say sample1, and so now spec. So these are the quite common words for any resource. Okay, so now here inside here is I want to launch some containers. So you see this, my editor is actually auto-filling the things, but I'm not sure your editor can do that. Why? Because mine is a paid version. I'm not really sure that it does available on the free community edition as well. Okay, so just to check that, otherwise you have to type it. So the containers name, and basically I just want to use Nginx, and the image is also going to be Nginx. The same thing, kubectl run sample1 and image is Nginx. So that you just kept in a declarative format. That's it, nothing more than that. Okay. So kubectl apply -f and the file name. Okay, so then it was just gonna create whatever you had declared in that particular file. Now kubectl get space pods, and you can see that sample and sample1 also now. Okay, so which is actually okay, so which is actually yeah, Nginx running basically. So which is I mean some pod is running. So the pod is having only one container right now. Okay, so that's where what I'm trying to tell here is your pod might be having a minimum one or more containers. So pod is the least unit in Kubernetes. Pod should have at least one container inside that. We can have one or more as well. Okay, we can have more as well, but one is mandatory, and you're actually trying to do that. Okay, so yeah, so this is the basic thing. And next, like let's say if you go with the two containers, now how do I deal with that? So here there is two containers. I will just and the pod I'm going to call as sample2, and one run you run Nginx, and the other one I'm going to run as a CentOS. So image is a CentOS :7, and also I would like to give some command which is okay. So actually CentOS requires some commands all the time, you remember. So sleep command I'm putting. I'm just giving a command argument, and I'm actually giving a custom command. Okay, so the next thing which we have here is the next thing which we have is just run it. Okay, so kubectl get space pods. I can see the sample is running, but you see the information it is telling that it is 2 by 2 is ready. So that means there are, the total number of pods are, the total number of containers in that pod is 2, and 2 out of 2 is ready here. Okay, so that's what it is telling. And now what you can do here is you can execute some commands inside them, okay, just to understand what I'm actually trying to tell you here. So here, first the network information I'll try to show. So kubectl exec, okay, -it, so which is a sample2, and the container which is CentOS, and -- bash. So what you have done is, so you're telling I want to execute on sample2 pod, but on a container CentOS, I want to go into a CentOS particularly, okay, and execute a command called as bash. Okay, you got it. -id is for interactive, you know that. So kubectl, so here, like let's say netstart, or you can just give call localhost. So where is actually Nginx is running? Nginx is running on the other container. But actually, in this container, so which is CentOS container, if you give call localhost, you get the response, which is actually the Nginx other container. Since these two containers use the same network stack, it doesn't really know that it is actually running in this node or in this container or the other container. It doesn't really know at all. Okay, so the pod is controlling that. Okay, so pod is actually grouping them into the same network. So the Docker has options. It's just trying to use those particular options. That's it, nothing more than that. Okay, so that is how you so that is how you kind of um, that's how you kind of what we call so get the same network or same network stack. So the container to container, one container running one service talks to another container which is running some other service. So I mean, rather than actually going out of one node to another node, so there is some latency. Now actually container to container directly talking is going to make the things faster in the microservice world, basically. So this is more majorly for the microservice world, right? In the microservice world, your container to container, so one component to component, so need to closely bind together at the network layer. Okay, you need to closely. I mean, I'm not saying like so front end you keep one container, catalog you keep one container. That's not a good practice, by the way, though. Okay, so we're not going to do that, by the way. Okay, so like let's say in the catalog itself you have two components, assume. Okay, so those two components can be also designed on the network layer. Okay, can be designed on the network layer to communicate and use the Kubernetes kind of options, and use the features which provides the Kubernetes, and you kind of use some local host network and you communicate each other. Okay, so that is what the advantage you're going to get it. But ultimately the development has to be developed accordingly. Okay, so you don't think like Kubernetes just as a platform and you deploy it. No, the development also should be necessarily need to develop accordingly. Okay, so design accordingly. So that's what is the network sharing between the pod you have. Okay, and what I have next, directly set up pods. I'll start with add configuration information to the pods. Okay, so I want to add some information to the pod basically. Okay, so what kind of information I want to what kind of information I wanted to get it. So through some environment variables. So ultimately, even our application also requires a lot of environment variables, right? So we're passing to some service I want to pass some catalog information that is passed as an environment variable. Okay, so like that, environment variables are quite important. So how do we pass the environment variables, or how do we pass the environment basically? So here we are going to send it to env. So the name of the one is like, let's say URL, and basically the value is like, let's say google.com. So, and also you cannot run the direct changes on a pod. Okay, that means git space pull and do ls kubectl apply -f 02 pod, and actually those changes will not be implicated. It's actually telling it cannot actually do that. Okay, so that is the reason. So that is the reason. So what actually we are doing it here is so we have to delete the pod and do that, or else create a new pod. Okay, so to deal with this, actually I'm going to use a utility called as k9s. See, k9s is going to bring me a flexibility of just using some shortcuts to deal with the things. Now I want to delete a pod, so what I have to do, kubectl delete pod. Okay, delete pod, like let's say sample. So now I have to type all this command and I have to wait for that. Now you see actually on the k9s is actually trying to show you that it is getting terminated. That's okay. It was actually taking a longer times, and you have to type a lot big command basically. Okay, which will deprecate, or basically which will decrease your performance. And k9s is kind of makes your life easy. So now if I want to delete this pod, so you have something like kill the pod, so just you control K, that pod will go away in a single shot. Shortcuts basically makes your life easy. Okay, now I want to remove sample one also, control K, that will go away. Okay, that deletes that resource. So shortcuts will be there here. So control K to kill, question for help, if for it, describe, all these options are there. You can use as per your requirement. So kubectl apply -f and so 02 pod.yml file. Now on the down you can see that so it's actually happening. And even if I want to go inside a shell of this one also, the shell is there, you see this. So you press yes, it is asking which container you want to go into the shell, and you use CentOS and you env. So ultimately that google.com will come into picture. google.com comes into picture. So that is how you pass your environment variables. So you pass your environment variables into the pod. Okay, so that is what you have. And so now if you have a bunch of information, a lot of information you have, and in the project levels usually you'll have a lot of information. And if I want to pass one by one information, so hard coding on the YAML file is quite difficult. So that is where okay, you can go and so deal with the config maps YAML file. So config map is designed to so API version is v1, kind is kind of config map. Okay, so metadata and the name is actually going to be is sample, and the data actually here it's not a spec. Config map is actually a data, so that's where instead of spec actually it's coming as data. So the data is like, let's say a lot of information. So URL is so go to meeting.com, so probably something like that. So timing is like, let's say 7:30 a.m. IST. Okay, course is like, let's say DevOps, and like this you have bunch of information, and I want to pass all this information into the pod. Okay, so then what I can do is I can create a pod. Now you see this is one YAML file I'm writing. So, and now it is going to be another YAML file. So this is one YAML file, and now it is actually going to be another YAML file. And another YAML file is so just to create a pod like this, just go this. So Nginx is really not needed to remove that. And so env, basically it's not env now, actually env now it is env from okay, so env from config map reference, and the name of the config map is like, let's say sample. Now what actually you're doing is you're actually trying to take all the environment from a config map. So now all these three values will be get into the CentOS container automatically. Now let's go and run this. Git space pull. It's actually throwing an error saying that so unexpected arguments in the config map.yml file. Unexpected arguments. Config map key reference, the name, I don't know. So basically I just need to refer the documentation. So config maps Kubernetes. So env from, it's not there. env from Kubernetes. Yeah, it's actually config map and name. Okay, it's fine only. Name is sample and it's all fine. Env from config map reference, the name is okay. Okay, now what is the error? The error is stating that in the arcs. Okay, command you have, you can view this way. Okay, unexpected arguments. Where did I give something? Did it pull the code completely? I don't see any problem, by the way. Okay, so now where could be the problem? So I just want to identify. So env from, I comment it out. Okay, I just want to identify where the problem is from. So I will remove that section and just give git space full. Oh, I given two pod names. My bad. It's actually correct only. My command was mistake. I gave two file names. So which it was throwing an error. You can give multiple file names, but you have to give -f another file name. So I have given only one file name. So kubectl apply -f. But before to that, git pull. Yeah. Now go inside shell. Go to the k9s. Go to the shell. And so actually, if you give env, all those things will come into picture. So go to meeting.com, sound that emist. Okay, so this is how you kind of pass all the information. So even for us also, config map is a need. Why? Because in our project we have a lot of variables. I can keep it in one place and I can push it, get everything. Okay, so whichever the one my application want to read it, it will read that particular one. Okay, cool. And the next thing is so something like, so config map, you have something also called as a secret. Okay, so what is the secret is, it's kind of store the information in a little secret format. But it's not encrypted, actually it's encoded only. Okay, encoded means you can always decode. Encrypt also you can decrypt, but if you have only the encryption key, if you have only the encryption key with you, then only you can encrypt it or decrypt it. Okay, but encoding is nothing but if you know which algorithm it is being used to encode, you can always decode that. Okay, and so this brings only the flexibility when you actually go with RBAC. RBAC is nothing but role-based access control. So you can give a user to not to see the secrets, and he can see only the config maps. You can delegate certain access. So that's where next slide is. So the same gotomeeting.com so can be given in a encoded format. So now it is actually a secret. So now encoding format, you should give it in like, let's say echo. So echo gotomeeting.com pipe base 64. So you're getting this string. So you just take this string and put it over here. Okay, so now the environment from me is a secret key, a secret reference, and the name is sample. Okay, so this is what you're going to have, but actually it actually decrypts, sorry, not decrypts, it decodes and send us an environment variable. Let's see. Push the code. I'm just actually filling the old pod. Pull. Okay, so now it actually came to running. Go to the shell and you give env, so still you get go to meeting.com. Okay, you still get go to meeting.com. So that is where so that is where you are going to pass some secret information. Like certain normal users, you don't give the access to the secret, so that's where he never sees the secret. And don't allow him to execute some shell commands also. He cannot execute a shell command, so that's where even if he so that's where he cannot execute the env command so that he can see the data. Okay, so that is where it's a so that is where it is it's a secret. So basically it just encodes and keep it the data and you keep it. All right, so that's what you have. And so the next thing which we have is so the next thing which you have is health checks basically. Okay, so now you need to decide whether your pod is really working fine or not working fine. Okay, so how can you do that? So if it is an Nginx, I probably check continuously whether my Nginx is actually dealing the things properly or not. Okay, so what I'm going to do is file, yeah. So API version is v1, kind is actually going to be pod, and metadata, the name is actually going to be is health check pod, and spec is actually going to be container C is health. Image is actually going to be or/d53 hyphen health check. Okay, so this is what actually you're trying to do. And now I'll go and give new file. No new file. So basically I'll try to create a Docker, and inside that I'll say inside that is gonna be health check, and inside that I'll keep a Docker file so that just some hierarchy easier. So here from nginx, rather than nginx, I'll just go and give from CentOS, okay, :7, and run yum install epl-release-y and run yum install nginx-y. Okay, so your nginx will be installed, and cmd, you need to run some command by default, and expose is basically 80 for the information that you're opening the 80 port. So nginx cmd, so nginx cmd docker nginx cmd docker file. Okay, for nginx, what is the default cmd? We can keep it. Okay, so you can, so this is what the thing you can keep it. Okay, nginx-g daemon off. So that is what we have to say to start the service of nginx, and it start the nginx service. But actually, rather than directly starting the nginx service, what I can do is I can just go and so say here okay, let me, rather than this, I will do I really need nginx? No. So I will just give cmd is thousand, or even this also is not needed. So I'm going to say that, so copy run.sh to slash and then run chmod +x run.sh. Okay, and CMD is actually going to be run the script, and I'll control it everything from the script run.sh. Okay, so that's what you're going to say, and here I will go and say run.sh. Okay, and in run.sh, so what actually I'm going to do here is what we call in run.sh, what we're going to do is it's a shell script basically /bin/bash. Okay, so touch /opt/file.txt file. Okay, so here while true do sleep for so 60 seconds, sleep for 60, and rm-f of slash opt/file.txt file, and done. Okay, what you're actually trying to do is so after 60 seconds you remove the file, and even the loop is also not needed. So just in case so my health check didn't determine, okay, so I just want to create this file. So touch this file, and actually I'm going to go do a health check saying that file based health check. I'm actually going to do a health check which is file based, or you can just say it by using network based, like so checking the port, or you can check that by using HTTP response based. So three things you have. I'm actually doing a file based one. So my health check, what I'm going to do here is I'm actually going to do by using file checks. So cd images, then here, so docker build -t /d3 open. Okay, so this is what you have, and docker push, and you have this image, and now coming to health check, so you have that particular one. All right, so now in the health check, so what all the health checks which you have available is first we'll start with liveness probe Kubernetes. Okay, so yeah, liveness probe, so we're actually trying to check a file cat so this one and this one, liveness probe. Even this guy is also explaining with a file based one only. So liveness probe, execute a command cat /tmp/healthy. No, not our case, actually opt/file.txt, and initially wait for 5 seconds and check every 5 seconds. Initially check or wait for 5 seconds and check it, initial delay seconds. After that you are saying periodic seconds is fine, so every 5 seconds you have to check it. Okay, so this is what the information which we have, and or the liveness you have checked. So now what it is going to happen is it's actually going to do a self health check. So that means the pod is continuously going to check the monitor the pod, and if it is actually doing bad, actually it's going to restart it. Okay, in the container also I have told you the same thing. So here, so now you observe basically what's going to happen here is it's actually so ready, it is running. Currently the restarts are 0. So after 60 seconds I'm going to remove the file. Okay, and we'll wait for automatically the pod restarts will be shown up here. Okay, let's wait for that. the health check is now you see this. So the restarts are actually there. It's one restart happened because, and also if you look into the kubectl kubectl describe pod, okay, of health check. Okay, so describe pod of health check. So what it is actually telling here is, what actually it is trying to tell you here is, okay, so created container health, started container health, or so first, even before logs, actually, if you see, so cat this failed, container health check failed, liveness probe will be restarted. Okay, so that means it's actually restarted it. All right, so that is how it actually restarted. And if you wait for another minute, again one more restart will happen continuously. It restarts. Okay, it has a capability of monitoring its pods, and it actually restarted pods if something goes wrong. Okay, so now, as of now, we are actually intentionally simulating the issue. But basically, so think about in certain cases, like so like most of the process, like majorly around the Java process. So Java process, sometimes the service always will be up. I mean, the process always shows is up, but the service will never be up. Okay, in some kind of scenarios, basically the process will be hung usually, so we need to just do a restart, it kind of fix the issues. So to avoid, to make those particular issues happen, or make those particular issues sorted out automatically, this liveness probe really helps you. And sometimes, so the application takes a lot of boot time basically. Okay, so and the next one is readiness probe. And sometimes your application takes a lot of boot time, so you need to wait for some time to get it solved, or you need to keep it under what we call, we need to keep it under okay, hold, so until my container really comes up. Okay, so in that particular scenario, so how do you deal with that? So that's where the readiness probe comes into picture. So for the first time, while the pod is actually booting it up, for the first time while the pod is coming up, okay, that time the readiness probe will come into picture. Okay, so readiness probe, majorly if we go and talk about a service, and then readiness probe will make sense. So that is the reason we'll go with readiness probe, and we'll talk about from there. Okay, so readiness probe, I'll talk about this particular one, and we'll move on. So just to conclude, like what all the things we have talked about so far. So we just talked about how do you create a pod, and how do you so kind of add the configuration information to the pod, and how do you make your pod self-heal automatically, so by using some liveness probe. Okay, readiness probe is something, while it is booting it up, you need to wait for some time to make the service up and running. So that's where is readiness probe comes into picture. Okay, so the next one is resources. I think probably we can hold it up, and we can take in tomorrow's session. So tomorrow we'll talk about resources, and then the services once again, and then we can go back to sets. Okay, so set up pods. Rather than one pod we don't run all the time, so it brings a problem of scalability. So that is where so that is where we'll need to go for set up pods. Okay, yeah, I think we can decent, we can stop here. Any questions? So I'm just deleting the cluster. EKS delete cluster -m name test and region use east1. So it will just delete the cluster. So whenever I want cluster, I'll just launch it by using this one, and whenever I don't want it, so kind of destroy it. Okay, so that's why we just use this EKS-CTL to delete it in better way. Okay, all right. I think a few minutes early, but still okay. So we can meet in tomorrow's session, and we'll continue from there. Okay, thank you. See you tomorrow. Bye. Good day. Good night.